if we are considering this as a earth surface, the normal procedure is nothing but whatever sun is there, that sun is radiating the heat, or because of sun radiation, um, so whatever heat is or whatever temperature is maintained on the earth surface, that is mainly because of the sun. So what actually is taking place? So wait for 1 minute, I'll change the color. So what is happening presently? So whatever sun radiations are there, so sun radiations are coming on the earth surface through the atmosphere. So here in between sun and earth surface there will be the atmosphere. So whatever sun radiations are there, those will be of short wave length, and whenever those sun radiation will strike on the earth surface, those sun radiation will be reflected. Those sun radiation will be reflected. So here, whenever those sun radiation will strike on the earth surface, there small amount of energy, small amount of energy will be released, and here along with whatever reflected rays will be there, so along with that reflected ray, the remaining amount of energy will be escaped. So here this long wavelength rays will be escaped into the atmosphere. But what actually is happening, because of leakage of various refrigerant into the earth surface or surrounding to the earth surface, what is happening, if there will be the if those refrigerant will get mixed with the environment. So if those refrigerants are consisting of carbon dioxide, those refrigerants are consisting of carbon dioxide, then CFC, chlorofluorocarbon, then chlorine, then hydrogen, because we are knowing that all the refrigerants are made up of the chemical formulas. So if those refrigerants are consisting of carbon dioxide, CFC, then HFC, as well as chlorine, as well as hydrogen, then these gases, whenever those refrigerant will mix inside the atmosphere or environment, then these gases will prevent the, or these gases will absorb the reflected rays. So whatever rays are being reflected from the earth surface, so those reflected rays will not be escaped from this, or because of this various gases. And as those gases are absorbing these reflected rays, so as that reflected rays are consisting of some amount of energy, so because of this, here temperature surrounding to the earth surface is goes on increasing gradually. Because of this, as these gases are absorbing the reflected rays, and as that reflected rays are consisting of the energy, so because of this same, here the temperature of the earth surface will goes on increasing gradually. And what is happening if the temperature of earth surface will goes on increasing gradually? So we are knowing that on the earth surface there a maximum percentage of, there about near about 71% of earth surface is covered with the water, and the remaining percentage, that is 21 percentage, sorry 29 percentage, is of earth or ground level. But out of that 71 percentage of water, maximum percentage of water is in the form of ice. So if the surrounding temperature of earth surface will goes on increasing, because of the same, the melting of ice will take place. And if that ice which is of which is in huge quantity, if that ice will start melting, so water surface level in the or sea level will goes on increasing, or water level inside the sea will goes on increasing. And because of the same, it will affect adversely on the environment. So this is called as a global warming. This is called as a global warming. And because of which factor that global warming is taking place, that global warming is mainly taking place because of the leakage of the refrigerant, which are consisting of carbon dioxide, CFC, HFC, chlorine. And whenever those gases will mix in the surrounding atmosphere, those gases will prevent the reflection of the, or prevent the reflection of the infrared radiation, that is nothing but the long wavelength radiations which are reflected from the earth surface. So that will be called as the global warming. So out of those all the gases, the major contribution in the global warming is because of the carbon dioxide as well as HFC refrigerant. So this is the first adverse effect of the refrigerant on the environment. Second adverse effect of the refrigerant on the environment is nothing but the ozone depletion. Second adverse effect on the second adverse effect of the refrigerant on the environment is nothing but the ozone depletion. As we are knowing that, so here if you are going to consider this as the earth surface. So above the earth surface, there are number of layers. So here, if you are going to consider the distance from the earth surface, that is from 10 kilometer to 50 kilometer. If you are going to consider this as a 10 kilometer and this distance as a up to 50 kilometer. So in the layer between 10 kilometer to 50 kilometer, in the layer between 10 kilometer to 50 kilometer, there will be the ozone layer. There will be the ozone layer. Ozone is nothing but O3. O3 molecule is called as a ozone layer. And because of this ozone layer, what those ozone layer or what that ozone layer is doing, that is absorbing the harmful gases, that is absorbing the harmful radiations which are coming from the sun. That means, as we are knowing that sun is radiating the heat. So whenever whenever sun radiations will fall on the earth surface, sun radiation will fall on the earth surface. So in that sun rays there will be the harmful radiation, and those harmful radiation will affecting on the human being. That means because of those harmful radiation, there will be the chances of cataracts as well as skin cancer as well as immunity system, or the level of immunity system will goes on decreasing. So those are the harmful gases. So whatever ozone layer is present in between the 10 kilometer to 50 kilometer region, that ozone layer is absorbing the harmful gases which are being transmitted to the earth surface. So what is happening whenever there will be the leakage of refrigerant? Whenever there will be the leakage of refrigerant, and if that refrigerant is consisting of the chlorine atom. So if you are going to consider any of the CFC type of refrigerant, any of the CFC type of refrigerant, CFC is nothing but chlorofluorocarbon type of refrigerant. So if you are going to consider the example of R11, R12 or R22, those will consisting of the chlorine atom. So if I'm going to consider the example of R11, R11 is nothing but CCl3F, trichloro monofluoro methane, that will be called as the R11. So whenever that R11 or any of the CFC refrigerant will come in contact with the ultraviolet rays, suppose here there is a leakage of R11 refrigerant. So whenever there will be the leakage of R11 refrigerant, that R11 refrigerant will get mixed in the surrounding atmosphere. So here, as we are knowing that whatever sun rays are coming on the earth surface, those are consisting of ultraviolet radiation. So whenever those ultraviolet radiation will come in contact with the R11 or any of the CFC refrigerant, then there will be the decomposition of that CFC refrigerant. That means because of contact of ultraviolet radiation with CCl3F, there will be the formation of chlorine. And the byproduct will be CCl2F. That means because of reaction with ultraviolet rays, there will be the formation of chlorine atom. Now whenever that chlorine atom, that means here that chlorine atom is separated, being separated from the refrigerant, that is nothing but CFC refrigerant. Now whenever that chlorine atom will come in contact with the ozone molecule, That means ozone is nothing but O3. Ozone is nothing but O3. So here that chlorine atom will consume the ozone molecule. That consumption of ozone molecule means because of that chlorine atom, there will be the destroying of ozone molecule. So whenever that reaction will take place, because of this reaction, there will be the formation of ClO. There will be the formation of ClO plus oxygen. There will be the formation of ClO plus oxygen, and when that ClO, that is nothing but compound of uh, oxychloride. So whenever that ClO will come with contact with the inert oxygen, then again there will be the formation of chlorine. Again there will be the formation of chlorine plus oxygen. Now here you will observe that. Here you will observe that because of 1 minute, I'll change the color. Here you will observe that because of leakage of CFC type of refrigerant, there is a formation of chlorine gas, or there is a formation of chlorine atom. And when that chlorine atom will come in contact with the ozone molecule, when that chlorine atom will come in contact with the ozone molecule, that ozone molecule will get destroyed, and again there will be the formation of chlorine atom. Now this chlorine atom will consume another ozone molecule, and then again there will be the formation of chlorine atom. That chlorine atom will again consume ozone molecule. So here if you see, one chlorine atom will consume near about 1 lakh of the ozone molecule. So if one chlorine atom is having the tendency, to consume near about 1 lakh of the ozone molecule, then what will happen? Then there will be the whatever ozone layer will be there. So that ozone layer will have the hole, or that hole will be formed in the ozone layer. And if that ultraviolet rays will directly come on the earth surface, then there will be that ultraviolet radiation will affect, or that ultraviolet radiation will affect adversely on the human being. So we have to choose the refrigerant. In such a way that if by chance there will be the leakage of that refrigerant, then also there should not be the formation of chlorine atom. So when there will not be the formation of chlorine atom, if you are not going to choose the CFC type of refrigerant, then there will not be the formation of chlorine atom. And if there will not be the formation of chlorine atom, then there will not be the depletion of ozone layer, or there will not be the consumption of ozone molecule. So because of the same, here monocol protocol, that one regulation committee is there. That regulation committee has banned all the CFC type of refrigerant in day-to-day use or day-to-day application, because those are consuming the ozone molecule. So this entire concept is called as a ozone depletion. Yesterday, because of hurry, or as my laptop was not charged, as well as that electricity problem was there, because of the same I was not able to convey the same message or convey the same knowledge to you people. That's why I have repeated both the thing today. Have you understood the concept of ozone depletion as well as global warming? Yes or no? Okay. So this is called as a ozone depletion. But for 1 minute. Okay. So that ozone depletion is mainly caused because of the CFC, or leakage of the CFC refrigerant inside the atmosphere. Wait for 1 minute. Okay. So because of CFC refrigerant, or because of leakage of CFC refrigerant into the atmosphere, there will be the formation of chlorine atom, and that chlorine atom will absorb, or that chlorine atom will consume the ozone molecule. And because of consumption of maximum amount of ozone molecule, there will be the formation of hole to that ozone layer. And if that ozone layer will be having the hole, so through that hole, all the ultraviolet rays which are coming from the sun will directly come on the earth surface, and that will affect adversely on the human being. So diagrammatically, that ozone depletion is explained here. So consider this as a sun rays, or this is the sun through which that ultraviolet rays are coming. And if you are going to consider this as the earth surface, this is nothing but the earth surface. So from earth surface 0 to 10 kilometer, 0 to 10 kilometer, whatever this layer will be there, that will be called as a troposphere. That will be called as a troposphere. And from 10 kilometer to 50 kilometer, from 10 kilometer to 50 kilometer from the earth surface, whatever layer will be there, that will be called as a stratosphere. So that stratosphere is consisting of the ozone layer. That stratosphere is consisting of the ozone layer. And what is the function of that ozone layer? That ozone layer or ozone is absorbing the harmful gases, absorbing the harmful radiations which are coming from the ultraviolet radiations. And because of the same, here on the earth surface, whatever radiations are coming through that ozone layer, that radiation will not have the harmful effect. But if we are using the CFC refrigerant, and by chance if there will be the leakage of CFC refrigerant, so that CFC refrigerant will mix inside the atmosphere. Now this is, if you see this, this is nothing but CCl3F, that is nothing but R11 refrigerant. So if that CFC refrigerant will mix inside the atmosphere, and if that CFC refrigerant will come in contact with the ultraviolet radiation, that CFC refrigerant will come in contact with the ultraviolet radiation, then there will be the formation of chlorine atom. So here, whatever this atom is there, that will be called as a chlorine atom. So here, whenever that chlorine atom will come in contact with the ozone, that O3 is called as the ozone molecule. Whenever that chlorine atom will come in contact with the ozone, then there will be the formation of oxygen. Plus ClO, chlorine oxygen. So here you are observing that this is nothing but the ClO. The byproduct of this combination of chlorine as well as O3 is nothing but ClO. This is nothing but chlorine, this is nothing but inert oxygen, and this is nothing but formation of oxygen. Now whenever that ClO will come in contact with the inert oxygen, then again there will be the formation of chlorine atom. Plus oxygen will be generated. So here one more chlorine atom will be generated. That one more chlorine atom will again consume the ozone molecule. Again there will be the formation of chlorine atom. Again that will consume the ozone molecule, and that cycle will continue. So one chlorine atom will have the tendency to absorb or consume near about 1 lakh of the ozone molecule. And because of the same, there will be the formation of hole in the ozone layer. So same is mentioned or same is explained with the help of this diagram. Any CFC, you can consider instead of R11, you can consider R12, R21, R22, any of the refrigerant. So whenever that will come in contact with the ultraviolet radiation, there will be the formation of chlorine atom. Whenever that chlorine atom will come in contact with the ozone molecule, there will be the formation of ClO plus oxygen. Whenever that ClO will come in contact with the inert oxygen, there will be again formation of chlorine atom. And that chlorine atom will again, that reaction will start again here. That chlorine atom will again consume the ozone molecule. So what are the adverse effects because of that ozone depletion? So whenever that ultraviolet radiation will directly fall on the earth surface, so what will happen? Because of that ultraviolet radiation, the skin cancer inside the human being will goes on increasing. Then there will be the suppression of human immunity response or human immunity system. So immunity system of human being will goes on decreasing or suppressing. Then there will be the increasing cataracts. Cataracts means this is one type of eye disease that is called as a motibindu. So the percentage of cataracts in the human or in the human eye will goes on increasing because of increasing the ultraviolet radiation. Then damage to the crops, then damage to the aquatic organism or organism, that is nothing but it will also affect on the aquatic organism, that is nothing but fishes as well as whatever uh, small organisms are there inside the water, that will also damage on that. Then increasing global warming. So those are nothing but the adverse effect because of the ozone depletion, because of the ozone depletion. So depending upon that ozone depletion and global warming, depending upon that ozone depletion and global warming, there are two terms. First term is called as the ODP. First term is called as the ODP. ODP is called as the ozone depletion potential. ODP is called as the ozone depletion potential, and second term is called as the GWP. Second term is called as the GWP. GWP is nothing but global warming potential. ODP is nothing but ozone depletion potential, and second one is nothing but GWP. GWP is nothing but global warming potential. In the name itself, you are able to see what is meant by ozone depletion potential. So the potential, or if you are going to consider any of the refrigerant, so because of that refrigerant, because of leakage of that refrigerant, how many ozone molecule will get depleted? How many ozone molecule will get depleted? That will be called as the ozone depletion potential. So in simple word, in some simple word, ozone depletion potential means ability of any of the refrigerant, ability of any of the refrigerant to deplete the ozone molecule, to deplete the ozone molecule, that will be called as the ozone depletion potential. आर यू गेटिंग? म्हणजे एखादा रेफ्रिजरंट कन्सिडर केला तर त्या रेफ्रिजरंटमुळे जर तो रेफ्रिजरंट जर लिकेज झाला तर त्या रेफ्रिजरंटमुळे ओझोन मॉलिक्यूल किती डिप्लीट होणार आहे किंवा किती डिस्ट्रॉय होणार आहे, त्याला काय म्हणणार आहे? त्याची ॲबिलिटी म्हणणार आहे, त्या रेफ्रिजरंटची ॲबिलिटी. आणि त्या रेफ्रिजरंटची ॲबिलिटी टू डिस्ट्रॉय द ओझोन मॉलिक्यूल विल बी कॉल्ड ॲज अ ओझोन डिप्लेशन पोटेन्शियल. सिमिलरली ग्लोबल वॉर्मिंग पोटेन्शियल म्हणजे काय? एखादा जर रेफ्रिजरंट लिकेज झाला, एखादा जर रेफ्रिजरंट लिकेज झाला आणि तो रेफ्रिजरंट लिकेज झाल्यामुळं ऍटमॉस्फिअर मध्ये मिक्स झाल्यामुळं त्या रेफ्रिजरंटच्या लिकेजमुळं जेवढं काय ग्लोबल वॉर्मिंग वाढणार आहे, जेवढं काय ग्लोबल वॉर्मिंग वाढणार आहे किंवा ॲबिलिटी ऑफ दॅट रेफ्रिजरंट, ability of that refrigerant to increase the global warming, that will be called as a global warming potential. Are you getting? ओझोन डिप्लेशन पोटेन्शियल आणि ग्लोबल वॉर्मिंग पोटेन्शियल दोन्ही म्हणजे काय? त्याची ॲबिलिटी किंवा कॅपॅसिटी त्या रेफ्रिजरंटमुळे किती ओझोन डिप्लेशन होणार आहे आणि त्या रेफ्रिजरंटच्या लिकेजमुळे किती ग्लोबल वॉर्मिंग इन्क्रीज होणार आहे, त्या ॲबिलिटीला आपण काय म्हणणार आहे? ओझोन डिप्लेशन पोटेन्शियल अँड ग्लोबल वॉर्मिंग पोटेन्शियल. हॅव यू अंडरस्टूड? येस ऑर नो? Okay, so as I have mentioned you that according to the Montreal protocol, this is one committee. According to the Montreal protocol, they have suggested that whatever refrigerant we have to use, that refrigerant should have the zero value of ODP. That refrigerant should have the zero value of ODP. That means ओझोन डिप्लेशन पोटेन्शियल किती पाहिजे त्या रेफ्रिजरंटचं? 0 पाहिजे. ओझोन डिप्लेशन पोटेन्शियल 0 याचा अर्थ काय? तो रेफ्रिजरंट जरी लिकेज झाला, बाय चान्स रेफ्रिजरंट जरी लिकेज झाला आणि ऍटमॉस्फिअर मध्ये मिक्स झाला तरी पण त्यामुळे जे काय ओझोन डिप्लेशन होणार होतं ते किती असलं पाहिजे? 0 असलं पाहिजे. आणि 0 ओडीपी कशाचं असणार आहे? द रेफ्रिजरंट विच आर नॉट consisting of chlorine or bromine atom. That's why whatever this Montreal protocol committee is there, that has banned all the CFC type of refrigerant. There is a banning of all the CFC type of refrigerant because CFC type of refrigerant is consisting of either chlorine or bromine atom, and that fluorine and bromine atom is causing the ozone depletion. So nowadays there is a banning on the CFC type of refrigerant. And the highest value of ozone depletion potential, is possessed by the R11 refrigerant. Highest value of ozone depletion potential is possessed by the R11 refrigerant. If you see the ODP value of R11, if you see the ODP value of R11 refrigerant, the ODP value of R11 refrigerant is nothing but 1, and that is the highest value. Highest value of ODP is nothing but 1, which is possessed by the R11 refrigerant. Second highest value of ODP, is being possessed by the R12 refrigerant, and that value of ODP for R12 is nothing but 0.92. So this is the second highest value of ODP possessed by the R12 refrigerant. So whatever R11, R12 as well as R21, R22, or in terms, whatever all these CFC type of refrigerants are there, those are in the phase out condition. That means we are not using those CFC type of refrigerant because those are possessing the highest value of ODP. Here we are using R12 as a refrigerant. R22 as a refrigerant. R11, R12 we have completely banned. But R22 refrigerant, though it is CFC type of refrigerant, but because of unavailability of proper alternative refrigerant, still we are using R22 as a refrigerant. But nowadays this R22 is also in the phase out condition. So in near future, that means in coming 3 to 4 years, that R22 refrigerant will be also absoluted, or that will be also banned. So that will be called as the ozone depletion potential. Similarly, another term is there that is called as a global warming potential. Another term is there that is called as a global warming potential. Global warming potential means potential or ability or capability to cause the global warming because of that refrigerant. Ability of any refrigerant or capability of any refrigerant to cause the global warming, that will be called as a global warming potential. So as that global warming is also adverse effect. So while selecting the refrigerant, we have to select the refrigerant which is having the low value of GWP as well as zero value of ODP. The refrigerant which is having the low value of GWP, global warming potential, and zero value of ozone depletion potential, those will be selected for the applications or any of the application. So highest value of global warming potential will be possessed by the carbon dioxide. Highest value of global warming potential will be possessed by the carbon dioxide, and that highest value of carbon dioxide or GDP value of carbon dioxide is nothing but 1. GDP value of carbon dioxide is nothing but the 1. So as you all are knowing that nowadays we are using R134A extensively in any of the application or in major application. So that R134A, sorry, not 34, R134A is nothing but the replacement for R12 refrigerant. Will tell me the chemical name of R134A? What is the chemical name of R134A? What is the chemical name? Can anyone tell me? What is the chemical name for R134A? That is called as a tetrafluoroethane. R134A is called as a tetrafluoroethane. If you see the chemical formula of R134A, you can afterwards you can find out. Tetrafluoro, that means 4 fluorine atoms are there. tetrafluoroethane, that is nothing but C2H2F4. That is the chemical name of R134A. So here if you see that R134A is not consisting of any of the chlorine atom. That is nothing but this is called as a HFC type of refrigerant. Wait for 1 minute. Okay. So here whatever R134A refrigerant is there, that is the HFC type of refrigerant. This is not the CFC type of refrigerant. HFC means hydrofluorocarbon type of refrigerant. Here if you see only hydrogen, fluorine and carbon atom will be present. No chlorine will be present in the R134A. That's why the OD value, ozone depletion potential value for R134A will be zero. Will be zero. It is having the zero value of ODP. But as this R134A is consisting of carbon as well as hydrogen bond. Carbon as well as hydrogen bond. That's why it will, or it is causing, or it is because of that R134A there is a global warming. So here that R134A is having the high value of GWP. That's why near future that R134A is not also the permanent solution. That is also not the permanent solution, though it is consisting of zero value of ODP. Though it is consisting of zero value of ODP, but it is having the higher value of GWP. That's why in near future that R134A we have to also replace by suitable refrigerant which is having the zero ODP as well as lower value of GWP. Are you getting? So this is the concept of ODP, ozone depletion potential, as well as global warming potential. Now next concept is there, that is called as the total equivalent warming impact. Total equivalent warming impact. सिंपल भाषेमध्ये सांगायचं झालं तर टोटल इक्विव्हॅलंट वॉर्मिंग इम्पॅक्ट म्हणजे काय? एखादा रेफ्रिजरंट ज्यावेळेस बाय चान्स लिकेज होतं एखाद्या रेफ्रिजरंटचं आणि ते लिकेज झाल्यामुळं त्या रेफ्रिजरंटचं डायरेक्ट ऍज वेल एज इनडायरेक्ट रिलीजमुळं ग्लोबल वॉर्मिंग किती इन्क्रीज होते इन टर्म्स ऑफ इयर. ग्लोबल वॉर्मिंग किती इन्क्रीज होते त्याला आपण काय म्हणणार आहे? टोटल इक्विव्हॅलंट वॉर्मिंग इम्पॅक्ट और टोटल इक्विव्हॅलंट वॉर्मिंग इंडेक्स, TEWI. So the factor TEWI that will consist of both direct as well as indirect emission. So direct emission means because of release into the atmosphere, and indirect emission means through energy consumption. So because of that, how much it will contribute, that refrigerant will contribute in the global warming, that impact will be called as a TEWI. So while selecting any of the refrigerant, naturally we have to select the refrigerant which is having the lower value of TEWI, lower value of total equivalent warming impact value. So it will be preferable if that refrigerant is having the lower value of TEWI, that will be preferable in the point of view of global warming. That means it will not cause the more and more amount of global warming. So this is the concept called as a total equivalent warming impact. And now last point is remaining. Sorry. Now last point is remaining, that is called as a alternative refrigerant. Last point is there. Actually, I don't have the slide of that last point. That's why I will write here. Alternative refrigerant. Okay, consider this as an alternative refrigerant. So we are knowing that in the present situation, we are having the number of refrigerant. In present situation, we are having the number of refrigerant, but still, we are in the find, or we are in the search of alternative refrigerant. Why this is so? Because whatever existing refrigerants are there, those existing refrigerants are having the ODP as well as GWP. That means those existing refrigerants are causing adversely on the environment by forming the global warming as well as ozone depletion. So we have to find out, or we have to search such a refrigerant which will have the lower value of ozone depletion potential and global warming potential. Now, if you see the example of R11, R12, R12, and R22. So all the three, that means R11, R12, as well as R22, all the three refrigerants are coming under the family of CFC type of refrigerant. So as all the refrigerants R11, R12, and R22, it's consisting of chlorine. That's why it is hugely impacting, or it is hugely affecting on the ozone depletion. That's why we have to find out the suitable refrigerant instead of using this refrigerant. And in application wise, if you see the application of these three refrigerants, there are huge application. Of R11, R12, as well as R22. So whatever monotrol protocol committee is there, they have already banned R11 refrigerant as well as R12 refrigerant. Instead of R11 refrigerant. Nowadays we are using the R123A refrigerant. Instead of R11 refrigerant, nowadays we are using R123A refrigerant. So whatever this R123A refrigerant is there, that is also compound of HCFC type of refrigerant. That is nothing but hydrochlorofluorocarbon type of refrigerant. Here again there is a chlorine atom. But here if you see the ozone depletion potential value, so the ozone depletion potential value for R11 was 1. But whatever R123A refrigerant is there, that R123A refrigerant is having the ozone depletion potential value as a 0.02. That means nearly equal to 0. That's why, and as that R123A refrigerant is having the more similar properties, or maximum properties of R123A refrigerants are similar to that of R11 refrigerant. Because if you see the boiling point temperature of R11 refrigerant, what was the boiling point temperature of R11 refrigerant? That was near about 29 degrees centigrade. Positive. So whatever R123A refrigerant is there, that R123A refrigerant is having the boiling point temperature as a 27.1 degrees centigrade. That is nearly equal to 29 degrees centigrade. And here we are knowing that R11 type of refrigerant was suitable for the centrifugal compressor. And that was applicable for the high tonnage capacity. Similarly, here that R123A type of refrigerant will be also suitable for the centrifugal compressor as well as high tonnage capacity. This refrigerant is also called as a SUPA. SUPA. R123 refrigerant is also called as a SUPA. and that is the replacement for R11 type of refrigerant. Are you getting? Now, for R12 refrigerant, what happened? Whether screen is visible? Hello? Whether screen is visible? No, wait for 1 minute. I think college net. Wait for 1 minute. I will connect laptop with the help of my hotspot. Don't leave the meeting or don't leave the lecture, because next lecture is also of mine. Because of connectivity issue, I lost the connection. So I have connected once again with the help of my laptop. I will reconnect. Wait for 1 minute. Okay. So the screen is visible now. Hello. Please give the reply. Whether the screen is visible to everyone. Okay. So we have seen the replacement for R11 refrigerant. So what is the replacement for R11 refrigerant? So R11 refrigerant is being replaced by the SUA, that is nothing but R123. R123A refrigerant. Sorry, that A should be here. So that is the first replacement. Now second replacement, as R12 refrigerant, that as R12 refrigerant are also possessing of most of the desirable properties, but as that, and there are also huge application of R12 refrigerant, but as that R12 refrigerant is CFC type of refrigerant and ozone depletion potential value for R12 is second highest, that is nothing but 0.92. So that monotrol protocol has banned that R12 refrigerant, and instead of R12 refrigerant, nowadays we are using R134A type of refrigerant. R134A, sorry, R134A type of refrigerant, that is called as a tetrafluoroethane, and this is the HFC type of refrigerant, hydrofluorocarbon type of refrigerant. This is the HFC type of refrigerant, hydrofluorocarbon type of refrigerant, because chemical name is tetrafluoroethane. So here that R134A is also possessing the similar properties. R134A is also possessing the similar properties as that of R12 refrigerant. What are the similar properties? If you see the boiling point temperature, the boiling point temperature of R12 refrigerant was near about minus 28 or 29 degrees centigrade. Minus 29 degrees centigrade. So whatever R134A refrigerant is there, that R134A refrigerant is having the boiling point temperature as a minus 26.2 degrees centigrade. Minus 26.2 degrees centigrade. And here the ozone depletion potential value. What was the ODP value for R12 refrigerant? What was the ODP value? That was second highest. That is nothing but 0.92. ODP value for R12 refrigerant was 0.92. But as that R134A refrigerant, it's HFC type of refrigerant. That means there is chlorine atom is absent in the R134A. That's why the ODP value for R134A is nothing but 0. But the global warming potential value of R134A refrigerant is higher as compared to R12 refrigerant, because the global warming potential value for R134A is nothing but 400, and that was 3700 for R12 refrigerant. That is the GWP value. So GWP value for R134A is higher as compared to the R12 refrigerant. That's why whatever R134A nowadays we are using extensively, that is also not the permanent solution. We have to find out the next refrigerant or one more alternative refrigerant which will have the 0 value of ozone depletion potential, as well as global warming potential value should be also lowest one. Are you getting? And nowadays, as there are huge applications of CFC refrigerant, so whatever R123A as well as whatever R134A refrigerants are there, those are not available in abundant quantity. So still we are using R22 refrigerant. Still we are using R22 refrigerant to fill the gap. That means to have the to fill the gap which is shortage of R134A as well as R123A. But this R22 refrigerant also in near future, that means in upcoming 3 to 4 years, that R22 refrigerant will also get phased out. Nowadays we are using very for very small application, or rarely we are using that R22 refrigerant. But that Monotrol protocol has also given the deadline for that R22 refrigerant. So, but nowadays we are using this refrigerant as a phase out refrigerant for CFC type of all the refrigerants. So this was nothing but our chapter number 3, that is nothing but the refrigerant. So here we have completed our chapter number 3 called as a refrigerant. Now we have to switch towards our next chapter, that is nothing but chapter number 4, and that chapter number 4 is nothing but vapor absorption refrigeration system. So we'll switch to the chapter number 4, which is nothing but vapor absorption refrigeration system. So in chapter number 1, we have seen the vapor compression refrigeration system. Then in chapter number 2, we have seen the multi-compression system or multi-pressure system. Chapter number 3 was related to the refrigerant, and last chapter from the section 1 is nothing but the vapor absorption refrigeration system. The syllabus for this chapter will be, first one will be the introduction, that is what is the exact meaning of vapor absorption refrigeration system, because that refrigeration system is broadly classified into 2 categories. Refrigeration system is broadly classified into 2 categories. First one is called as a vapor compression refrigeration system. Second one is called as a vapor absorption refrigeration system. So here first one is nothing but introduction. That vapor absorption refrigeration system is mainly consisting of 3 types. Out of that, first one is called as a simple aqua ammonia. Simple aqua ammonia vapor absorption system. That simple aqua ammonia vapor absorption system is also called as a simple water or simple ammonia water vapor absorption system. That is nothing but aqua ammonia vapor absorption system. Then second one is nothing but practical aqua ammonia vapor absorption system. So after seeing the simple aqua ammonia vapor absorption system, to make it more practicable or to make it more practicable, we have to make some changes or we have to add some accessory. So after adding some accessory, whatever aqua ammonia system will be there, that will be called as a practical aqua ammonia vapor absorption system. Then we have to see the basic difference between vapor compression and vapor absorption refrigeration system. Next point is nothing but we have to see the basic difference between vapor compression and vapor absorption refrigeration system. Then we have to find out or we have to find out the method how to calculate the COP of vapor absorption refrigeration system. That means by using the simple formula, what is the value of COP? COP is nothing but amount of heat absorbed or refrigerating effect divided by work done. So logically, we have to see how to calculate the value of COP for vapor absorption refrigeration system. Then second major system is nothing but Electrolux refrigeration system. Second system is called as a Electrolux refrigeration system. That is also called as a three-fluid refrigeration system. That is also called as a three-fluid vapor absorption refrigeration system. And last system is nothing but lithium bromide, or that is also called as a LIBR vapor absorption system. LIBR vapor absorption refrigeration system. And new mixtures for vapor absorption system. That will be the last point. So assignment, first question will be describe the simple aqua ammonia vapor absorption refrigeration system with the help of neat diagram. Second question will be compare vapor compression and vapor absorption refrigeration system. Then third point will be state the function of following components in absorption system with the help of neat diagram. That is nothing but absorber, rectifier, analyzer, and heat exchanger. Then fourth one is nothing but draw a neat diagram of LIBR, that is nothing but lithium bromide vapor absorption refrigeration system, and explain its working. And last point is nothing but explain with the help of neat diagram Electrolux refrigeration system. So I will give the 5 minutes. In that 5 minutes, you have to write down all the 5 questions as an assignment question. Sorry, you have to note down this slide. So write down assignment number 4 and write down this 5 questions. Simple aqua ammonia vapor absorption, then comparison between vapor compression, vapor absorption. Third question is related to practical aqua ammonia. Fourth one is related to LIBR vapor absorption. And fifth one is related to the Electrolux refrigeration system. Purposefully, I have given 5 minutes so that I will get or I will have some amount of rest, and after that I will continue because still 45 minutes I have to speak, and that too one-way communication. For how much chapter I have given you the notes? Can anyone tell me? How many chapters notes I have provided to you people? Anyone can unmute and can tell me. Chapter number 1, whether I have provided all the notes? Hello? Anyone? Gaurav, unmute yourself and tell me. For how many chapters I have provided you notes?
So I think first and second chapter provided.
Second chapter, whether I have provided all the notes? Yes or no?
I will check.
Okay. Remaining student, who is knowing? Volsange.
Yes, sir.
Whether I have provided the notes for second chapter?
I also don't know, sir. First chapter you have given, sir.
Okay.
No, sir. Second chapter not given.
Okay. Today I will provide the notes for chapter number 2 as well as chapter number 3. And what about PPT? For which chapter I have provided the PPT? Chapter number 1, I think I have provided. Chapter number 2 also, I think I have provided. For chapter number 2, whether I have provided the PPT? Yes or no? Okay. I think third chapter is remain. So for third chapter also, today I will provide the PPT. Have you written this? Yes or no? Okay. Now we'll start our vapor absorption refrigeration system. Now, what is meant by vapor absorption refrigeration system? So, wait. So in the chapter number 1, we have seen the vapor compression refrigeration system. So we are knowing that vapor compression refrigeration system is consisting of the compressor, then outlet of compressor will be provided. Outlet of compressor will be provided to the condenser. This will be the condenser. Here heat will be rejected. Then outlet of condenser will be provided to the expansion device. Here pressure will be reduced from high pressure to the low pressure, and outlet of evaporator, outlet of expansion valve will be provided to the evaporator, where actual heat absorption process will take place. This will be the evaporator, and outlet of evaporator will be again given to the compressor. Now, here, for what purpose we were provided the compressor in vapor compression refrigeration system? For what purpose we have provided compressor in vapor compression refrigeration system? Can anyone tell me? कॉम्प्रेसर कशासाठी प्रोव्हाइड केला होता? कोणी सांगा. टू इन्क्रीज द प्रेशर फ्रॉम लोअर प्रेशर टू द हायर प्रेशर. म्हणजे कॉम्प्रेसरच्या इनलेटला आपल्याकडे काय होतं? इव्हापरेटिंग प्रेशर होतं. दॅट इज नथिंग बट लोअर प्रेशर. आणि कॉम्प्रेसरच्या आउटलेटला आपल्याला काय भेटत होतं? हायर प्रेशर भेटत होतं. दॅट इज नथिंग बट दी कंडेन्सर प्रेशर. आणि हा प्रेशर डिफरन्समुळे काय होत होतं? जर हा प्रेशर डिफरन्स जर आपण क्रिएट केला नसता तर काय झालं असतं? कोण सांगेल? जर आपण हा प्रेशर डिफरन्स क्रिएट केला नसता तर काय झालं असतं? कशामुळे हायर प्रेशर आपण कंडेन्सरला देतोय, लोअर प्रेशर आपण इव्हापरेटरला देतोय? कोण सांगेल रिझन? कशासाठी आपण हायर प्रेशर कंडेन्सरला आणि लोअर प्रेशर इव्हापरेटरला देतोय? The main reason is that in case of vapor compression refrigeration system, we require Oh, okay. Only 1 minute. I'm getting one urgent call. I will take it, and within 1 minute, I will continue. Hello. Okay. So here, for what purpose we were increasing the pressure? Because of increasing the pressure, here we are easily able to convert paper refrigerant into liquid refrigerant. Paper refrigerant into liquid refrigerant. Why? Because here, in case of condenser, we require to reject the heat. In case of condenser, we require to reject the heat, and whenever we are providing the higher pressure refrigerant to the condenser, because of increasing the pressure, the boiling point temperature of that refrigerant will also goes on increasing. And as boiling point temperature of that refrigerant is being increased, that's why easily there will be the conversion of paper refrigerant into liquid refrigerant. And inside the evaporator, so evaporator will be working at a lower pressure, that is nothing but evaporating pressure. So at the inlet of evaporator, we are having the liquid, maximum percentage of liquid and very small amount of vapor. So as we are providing the lower pressure inside the evaporator, so because of lower pressure, here boiling point temperature of that refrigerant will goes on decreasing. And as boiling point temperature of that refrigerant is decreased, that's why here that refrigerant will easily convert, or that refrigerant will easily evaporate, and because of the same, that liquid refrigerant will get converted into vapor refrigerant. So that was the main function, or that was the main purpose of using the compressor. But to run that compressor, we require to provide the electricity. To run that compressor, we require to provide the electricity, as well as we are knowing that that compressor is consisting of number of moving parts. And as that compressor is consisting of number of moving parts, that's why chances of leakage of refrigerant in case of vapor compression refrigeration systems are much more. And if by chance there will be the leakage of refrigerant, we are knowing the adverse effect which are being caused by the refrigerant. That means that refrigerant will cause the global warming as well as ozone depletion. So to avoid all those things, that means here, if you see, suppose I want to produce the refrigerating effect, but the place where I want to produce the refrigerating effect, that place is not consisting of, or that place is not having the availability of electricity. So if availability of electricity will not be there, then whether we are able to produce the refrigerating effect with the help of that vapor compression refrigeration system, that will not be possible because electricity is required. Electricity is required to run the compressor. So here, whatever vapor absorption refrigeration system is there, whatever vapor absorption refrigeration system is there, the main reason or the main motto why we have to use the vapor absorption refrigeration system is with the help of that vapor absorption refrigeration system. That means in case of vapor absorption refrigeration system, we are using heat energy or waste heat. We are using heat energy or waste heat instead of mechanical work compressor. So if that electricity is not available, then to obtain the refrigerating effect, we require to use the heat energy. So in case of vapor absorption refrigeration system, instead of mechanical work or instead of electrical energy, we are using the heat energy. Or steam, or we are using the waste energy which is coming out of the power plant, and with the help of that we are able to produce the refrigerating effect. So what is the major difference between vapor compression refrigeration system and vapor absorption refrigeration system? So the major difference between vapor compression and vapor absorption refrigeration system will be we have to replace the compressor. If we are going to replace the compressor from vapor compression refrigeration system with the help of here I will change the color, absorber, then pump, then generator, and pressure reducing valve. So if the compressor from vapor compression refrigeration system, if the compressor from vapor compressor or vapor compression refrigeration system will be replaced by absorber, pump, generator and pressure reducing valve. So whatever this assembly, absorber, pump, generator and pressure reducing valve will be there, that will have the same function, as that of compressor. That means to increase the pressure from evaporating pressure to condenser pressure, and because of increasing the pressure there will be ease to change the phase of refrigerant. So if we are going to replace the compressor from vapor compression refrigeration system by absorber, pump, generator and pressure reducing valve, then whatever system will be formed, that system will be called as a vapor absorption refrigeration system. That system will be called as a vapor absorption refrigeration system. Are you getting the basic difference between vapor compression and vapor absorption? आपल्याला काय करायचं आहे, फक्त vapor compression refrigeration system मधला कॉम्प्रेसर कशाने रिप्लेस करायचा आहे, ऍब्झॉर्बर, पंप, जनरेटर अँड प्रेशर रिड्युसिंग वॉल्व. जर आपण वेपर कॉम्प्रेशन सिस्टीम मधला कॉम्प्रेसर, ऍब्झॉर्बर, पंप, जनरेटर अँड प्रेशर रिड्युसिंग वॉल्व त्या असेंब्लीने रिप्लेस केला आणि रेस्ट ऑफ सिस्टीम जर सेम ऍज इट इज ठेवली, रेस्ट ऑफ सिस्टीम ही जी काय बाकी सिस्टीम आहे ऍज इट इज ठेवली, तर जी काय प्रोड्यूस होणारी सिस्टीम आहे त्याला काय म्हणणार आहे मी, वेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम. आणि जे काय आपण ऍब्झॉर्बर, पंप, जनरेटर आणि प्रेशर रिड्युसिंग वॉल्व यूज करणार आहे त्याचं फंक्शन काय असणार आहे, सेम ऍज दॅट ऑफ कॉम्प्रेसर असणार आहे. फक्त फरक काय असणार आहे, सेम ऍज दॅट ऑफ कॉम्प्रेसर म्हणजे ते पण ऍब्झॉर्बर, पंप, जनरेटर आणि प्रेशर रिड्युसिंग वॉल्व काय करणार आहे, इव्हापोरेटिंग प्रेशरचं कन्वर्जन कंडेन्सर प्रेशर मध्ये करणार आहे. फक्त फरक काय असणार आहे दोन्हीमध्ये, त्या कॉम्प्रेसर मध्ये कॉम्प्रेसर रन करण्यासाठी आपल्याला काय लागत होती, इलेक्ट्रिकल एनर्जी लागत होती किंवा इलेक्ट्रिसिटी लागत होती. पण हा ऍब्झॉर्बर, पंप, जनरेटर आणि प्रेशर रिड्युसिंग वॉल्व ही असेंब्ली यूज केल्यामुळे आपण काय करू शकतोय, जे काय एक्झॉस्ट गॅसेस आहेत किंवा जे काय वेस्टेज ऑफ हीट वेस्टेज होणारी हीट होती किंवा जी काही हीट एनर्जी आहे ती काय आपण यूज करून काय करणार आहे, इव्हापोरेटिंग प्रेशरचं कंडेन्सर प्रेशर मध्ये कन्वर्जन करणार आहे. आणि दुसरा ऍडव्हान्टेज काय, कॉम्प्रेसर मध्ये काय होतं, नंबर ऑफ मुव्हिंग पार्ट्स होते. पण ही जी काय असेंब्ली आहे त्या असेंब्लीमध्ये काय असणार आहे, नंबर ऑफ मुव्हिंग पार्ट्स जे आहेत ते आपण काय केलेले आहेत, रिड्यूस केलेले आहेत. आणि नंबर ऑफ मुव्हिंग पार्ट्स रिड्यूस केल्यामुळे काय होणार आहे, चान्सेस ऑफ लिकेज ऑफ रेफ्रिजरंट जे आहेत, चान्सेस ऑफ लिकेज ऑफ रेफ्रिजरंट जे आहे ते काय होणार आहे, रिड्यूस होणार आहे. तर त्या सिस्टीमला आपण काय म्हणणार आहे, पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम. बाकीचे जे पार्ट आहेत म्हणजे आउटलेट ऑफ कॉम्प्रेसर कशाला देत होतो आपण, कंडेन्सरला देत होतो. तर ह्या असेंब्लीचा आउटलेट जे आहे ते कशाला देणार आहे, कंडेन्सरला देणार आहे. कंडेन्सरचा आउटलेट परत कशाला देणार आहे आपण, एक्सपान्शन वॉलला देणार आहे. एक्सपान्शन वॉलचा आउटलेट परत कशाला देणार आहे, इव्हापोरेटरला. फक्त इव्हापोरेटरचा आउटलेट कॉम्प्रेसरला द्यायच्या ऐवजी त्या असेंब्लीला देणार आहे. ऍब्झॉर्बर, पंप, जनरेटर आणि प्रेशर रिड्युसिंग वॉल. त्यावेळेस जी काय सिस्टीम फॉर्म होणार आहे त्याला काय म्हणणार आहे मी, पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम. तर ह्या पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीमच्या 4 सिस्टीम आहेत. त्यापैकी पहिली जी आहे त्याला काय म्हणतो आपण, सिंपल ॲक्वा अमोनिया पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम. सिंपल ॲक्वा अमोनिया पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम. त्या सिंपल ॲक्वा अमोनियामध्ये थोडेफार चेंजेस केले टू मेक दॅट सिस्टीम ॲज अ प्रॅक्टिकेबल or practicable, that will be called as a practical aqua ammonia vapor absorption refrigeration system. Then whatever next system will be there, that will be called as the electrolux refrigeration system, that is also called as the three fluid vapor absorption refrigeration system. And whatever last system will be there, that last system will be called as a lithium bromide, LIBR vapor absorption refrigeration system. So only these 4 systems we have to see in this entire chapter. So after seeing these 4 systems, there will be the end of this our chapter number 4. So now we'll switch to our first system, that is nothing but simple aqua ammonia vapor absorption refrigeration system. फक्त तुम्ही काय कन्सिडर करा, 2 मिनिट. You have to consider that instead of this assembly, you have to consider that instead of this assembly there is a compressor. त्या असेंब्लीच्या ऐवजी आपल्याकडे काय आहे, ह्या ठिकाणी कॉम्प्रेसर आहे असं अज्युम करा. तर आपण काय करत असतो, कॉम्प्रेसरचं जे काही इनलेट असतं ते कशाचं आउटलेट असतं, इव्हापोरेटरचं आउटलेट असतं. हा जो आहे तो काय, इव्हापोरेटर. इव्हापोरेटर मध्ये प्रेशर कोणतं असणार आहे, इव्हापोरेटिंग प्रेशर असणार आहे. वेपरचं प्रेशर कोणतं असणार आहे, इव्हापोरेटिंग प्रेशर असणार आहे. त्या इव्हापोरेटिंग प्रेशरला काय होणार आहे, हीट ऍब्झॉर्प्शन होणार आहे. त्यामुळे ह्या ठिकाणी काय होणार आहे, लिक्विडचं कन्वर्जन किंवा लिक्विड प्लस पेपर मिक्सचरचं कन्वर्जन, लिक्विड प्लस पेपर मिक्सचरचं कन्वर्जन कशामध्ये होणार आहे, लो प्रेशर पेपर मध्ये होणार आहे. या ठिकाणी लो प्रेशर पेपर मध्ये किंवा इव्हापोरेटिंग प्रेशर पेपर मध्ये होणार आहे. इव्हापोरेटिंग प्रेशर पेपर मध्ये होणार आहे. हे इव्हापोरेटिंग प्रेशर पेपर कशाला देत असतो आपण, कॉम्प्रेसरला देत असतो. आणि कॉम्प्रेसर मध्ये काय करत असतो आपण, त्याचं कन्वर्जन, इव्हापोरेटिंग प्रेशरचं कन्वर्जन कशामध्ये करत असतो, कंडेन्सर प्रेशर मध्ये करत असतो. आणि पेपर काय होत असतात, सेमच राहत असतात. म्हणजे हाय प्रेशर पेपर मध्ये जनरेशन होत असतं. त्या हाय प्रेशर पेपर आपण कशाला देत असतो, नंतर कंडेन्सरला देत असतो. कंडेन्सर मध्ये काय करत असतो आपण, काहीतरी कुलिंग मीडियम, या ठिकाणी काय यूज केलेलं आहे, वॉटर, किंवा आपण काय यूज करू शकतो, एअर ॲज अ कुलिंग मीडियम यूज करू शकतो. कंडेन्सर मध्ये काय केलेलं असतं, हीट रिजेक्ट केली जाते, हीट रिजेक्ट केली जाते. आणि हीट रिजेक्ट केल्यामुळं, हाय प्रेशरला हीट रिजेक्ट केल्यामुळे काय होत असतं, पेपरचं कन्वर्जन कशामध्ये होत असतं, लिक्विड मध्ये होत असतं. पेपरचं कन्वर्जन लिक्विड मध्ये होत असतं. पण प्रेशर जे असतं ते काय राहत असतं, सेमच राहत असतं. दॅट इज नथिंग बट इव्हापोरेटिंग प्रेशरच राहत असतं. त्यानंतर आउटलेट ऑफ कंडेन्सर आपण कशाला देत असतो, रिसिव्हरला देत असतो. म्हणजे हाय प्रेशर लिक्विड रेफ्रिजरंट जे आहे ते कशाला जाणार आहे, आपल्या रिसिव्हरला जाणार आहे. रिसिव्हरचं फंक्शन काय असतं, फक्त कंडेन्सर कडून येणारं जे काही लिक्विड आहे ते रेग्युलेट करणं, एवढंच फंक्शन कशाचं असतं, रिसिव्हरचं असतं. आणि रिसिव्हरच्या आउटलेटला आपल्याला काय मिळणार आहे, सेम कंडेन्सर प्रेशर लिक्विड रेफ्रिजरंट भेटणार. कंडेन्सर प्रेशर लिक्विड रेफ्रिजरंट भेटणार. ते कंडेन्सर प्रेशर लिक्विड रेफ्रिजरंट आपण नंतर कशाला देत असतो, एक्सपान्शन वॉलला देत असतो. आणि एक्सपान्शन वॉल मध्ये काय होत असतं, आयसेंथाल्पिक एक्सपान्शन झाल्यामुळे काय होत असतं, कंडेन्सर प्रेशरचं कन्वर्जन इव्हापोरेटिंग प्रेशर मध्ये होत असतं. आणि लिक्विडचं कन्व्हर्जन लिक्विड प्लस पेपर मिक्सचर मध्ये होत असतं. ही झाली आपली पेपर कॉम्प्रेशन रेफ्रिजरेशन सिस्टीम. ही काय झाली आपली पेपर कॉम्प्रेशन रेफ्रिजरेशन सिस्टीम. आता फक्त मी काय करतोय त्या पेपर कॉम्प्रेशन रेफ्रिजरेशन सिस्टीम मधला पेपर कॉम्प्रेशन रेफ्रिजरेशन सिस्टीम मधला मी काय करतोय फक्त जो काय कॉम्प्रेसर जो होता तो कॉम्प्रेसर कशाने रिप्लेस करतोय मी ऍब्झॉर्बर. हा जो आहे तो ऍब्झॉर्बर आहे. त्यानंतर पंप हा जो आहे हा डिव्हाइस जो आहे त्याला काय म्हणतोय आपण पंप. त्यानंतर नेक्स्ट डिव्हाइस जो आहे तो हा जो डिव्हाइस आहे त्याला काय म्हणतोय मी जनरेटर. आणि हा जो डिव्हाइस आहे त्याला काय म्हणतोय प्रेशर रिड्युसिंग वॉल. जर मी हा कॉम्प्रेसर ऍब्झॉर्बर पंप जनरेटर आणि प्रेशर रिड्युसिंग वॉल न रिप्लेस केला, जर हा मी कॉम्प्रेसर पेपर कॉम्प्रेशन रेफ्रिजरेशन सिस्टीम मधला कॉम्प्रेसर जर मी ऍब्झॉर्बर पंप जनरेटर आणि प्रेशर रिड्युसिंग वॉल न रिप्लेस केला, ज्याचं की फंक्शन सेम एज दॅट ऑफ कॉम्प्रेसर होतं. कॉम्प्रेसरचं फंक्शन काय होतं लो प्रेशर पेपर रेफ्रिजरंटचं कन्वर्जन कशामध्ये करणार हाय प्रेशर पेपर रेफ्रिजरंट मध्ये. लो प्रेशर पेपर रेफ्रिजरंटचं कन्वर्जन हाय प्रेशर पेपर रेफ्रिजरंट मध्ये करणं एवढंच फंक्शन आहे कॉम्प्रेसरचं. ज्याचं की फंक्शन सेम एज दॅट ऑफ कॉम्प्रेसर आहे तर त्या सिस्टीमला काय म्हणणार आहे मी पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम म्हणणार आहे. समजतंय पेपर ऍब्झॉर्प्शन रेफ्रिजरेशन सिस्टीम. आणि रेस्ट ऑफ पार्ट जो आहे तो काय असणार आहे ऍज इट इज असणार आहे. म्हणजे मी हा कॉम्प्रेसर रिप्लेस केला कशानं ऍब्झॉर्बर पंप जनरेटर अँड प्रेशर रिड्युसिंग वॉल या 4 कंपोनंटनी हा कॉम्प्रेसर रिप्लेस केला. आणि बाकीची जी काय सिस्टीम आहे बाकीची सिस्टीम काय ऍज इट इज एज दॅट ऑफ कॉम्प्रेसर एज दॅट ऑफ पेपर कॉम्प्रेशन रेफ्रिजरेशन सिस्टीम. त्यावेळेस त्या सिस्टीमला मी काय म्हणतोय सिंपल और त्या सिस्टीमला काय म्हणतोय पेपर ऍब्झॉर्प्शन सिस्टीम म्हणतोय. समजतंय? रिप्लाय मध्ये सांगा येस और नो. आर यू गेटिंग द पॉइंट? Remaining student, out of 35 students, only 1 student or 2 student is getting. What about remaining student? If you are having any doubt up to this point, you can ask me. कोणाला काय डाऊट असतील तर विचारू शकता. आहे का डाऊट? Please ask if you are having any doubt. What about remaining student? That means only these many are active member. What about remaining student? Okay, let it be. So here I have replaced the compressor by the assembly called as the absorber, pump, generator and pressure reducing valve, which will replace the compressor from paper compression refrigeration system, and because of that paper absorption refrigeration system will be formed. Now how that this assembly will work effectively, that we have to see. Now here, as the name of system is aqua ammonia vapor absorption system, as the name of system is aqua ammonia vapor absorption system. What is the meaning of aqua? What is the meaning of aqua? Aqua means, what is the meaning of aqua? Aqua means water and ammonia. So here in this system ammonia as well as water will be used. In this system ammonia as well as water will be used, but out of that ammonia will be acting, out of that ammonia and water from aqua ammonia system, out of that ammonia and water, whatever ammonia will be there, that ammonia will be acting as a refrigerant. That ammonia will be acting as a refrigerant, and whatever aqua, that is nothing but water will be there, that water will be act as like a absorbent. वॉटरला काय म्हणतोय आपण ऍब्झॉर्बंट म्हणणार आहे. वॉटरला काय म्हणणार आहे ऍब्झॉर्बंट म्हणणार आहे, आणि अमोनियाला काय म्हणणार आहे रेफ्रिजरंट म्हणणार आहे. आणि जो काय ऍब्झॉर्बंट असतो, तो ऍब्झॉर्बंट जो काय ऍब्झॉर्बंट असणार आहे तो ऍब्झॉर्बंट फक्त कोणत्या सिस्टीम पुरता मर्यादित असणार आहे, जी काय आपण कॉम्प्रेसरनं रिप्लेस केलेली सिस्टीम आहे तेवढ्याच सिस्टीम पुरता काय असणार आहे तो ऍब्झॉर्बंट इफेक्टिव्ह असणार आहे किंवा तेवढाच ऍप्लिकेबल असणार आहे. पण जो काय रेफ्रिजरंट असणार आहे तो रेफ्रिजरंट काय होणार आहे, थ्रू आउट द सिस्टीम काय होणार आहे, सर्क्युलेट होणार आहे. आता जर आपण अमोनिया जर रेफ्रिजरंट जर कन्सिडर करत असेल तर काय असणार आहे, या ठिकाणी आउटलेट ऑफ इव्हापरेटर. आउटलेट ऑफ इव्हापरेटर आपल्याला काय भेटणार आहे, लो प्रेशर अमोनिया वेपर भेटणार आहे. म्हणजे इव्हापरेटिंग प्रेशर अमोनिया वेपर भेटणार आहे, लो प्रेशर अमोनिया वेपर भेटणार आहे. तो लो प्रेशर अमोनिया वेपर आपण कशाला देणार आहे, सुरुवातीला ऍब्झॉर्बरला देणार आहे. लो प्रेशर अमोनिया वेपर कशाला देणार आहे आपण, ऍब्झॉर्बरला. आता ह्या ठिकाणी काही जणांच्या मनामध्ये क्वेश्चन असेल का आपण ही पेअर कन्सिडर केलेली, कारण की सॉरी अमोनिया बरोबर वॉटरच का पेअर कन्सिडर केलेले, बिकॉज if you see the property of water, that water is having tendency to absorb very large ammonia of very large amount of ammonia vapor. water मध्ये काय कॅपॅसिटी आहे, to absorb the ammonia vapor at large quantity. ही टेंडन्सी आहे त्या वॉटरची. दॅट्स वाय अलॉंग विथ अमोनिया वी आर युझिंग absorbent as a water. So when that low pressure ammonia vapor will come towards the absorber, here inside the absorber that water, या ठिकाणी काय असणार आहे, वॉटर असणार आहे. water will absorb the maximum amount of ammonia vapor. water will absorb the maximum amount of ammonia vapor. So whenever that ammonia will be absorbed by the water, then there will be the formation of strong aqua ammonia solution. आणि हे जे काय स्ट्रॉंग aqua ammonia सोल्युशन असणार आहे ते स्ट्रॉंग aqua ammonia सोल्युशन कोणत्या प्रेशरला आहे, सेम प्रेशरला आहे, म्हणजे इव्हापरेटिंग प्रेशरला जाईल. स्ट्रॉंग aqua ammonia सोल्युशन कोणत्या प्रेशरला आहे, सेम इव्हापरेटिंग प्रेशरला आहे. सो दॅट स्ट्रॉंग aqua ammonia सोल्युशन विल बी पंप्ड. नाउ या ठिकाणी प्रेशर इन्क्रीज करण्यासाठी आपण काय यूज केलेलं आहे, पंप यूज केलेला आहे. इफ यू कन्सिडर द पंप, that pump will require that pump will have the less number of moving parts as compared to compressor, as well as the consumption of electricity which is required to run the pump will be less as compared to the compressor. So here that pump will pressurize that strong aqua ammonia solution, and because of that pressurization, here pressure will increase from evaporating pressure to condenser pressure or low pressure to high pressure. So here we will have the high pressure strong aqua ammonia solution. So that high pressure strong aqua ammonia solution will be provided to the generator. Now inside the generator we will have the heating coil. This is nothing but the heating coil, and through this heating coil you can pass the exhaust heat which is coming out of the power plant or which is coming out of the combustion or internal combustion engine also, or you can pass that steam also through this heating coil. So whenever through this heating coil we are passing the heat which is exhaust heat, or which whenever we are passing that waste heat, or whenever we are passing the steam. So because of passing the heat or steam, it will heat the strong aqua ammonia solution. Inside the generator. Now we are knowing the boiling point temperature of water and ammonia. What is the boiling point temperature of water? At 1 atmospheric pressure, 100 degrees centigrade. What about the boiling point temperature of ammonia? At 1 atmospheric pressure, ammonia, NH3. What is the boiling point temperature? Can anyone tell me? Refrigerant chapter मध्ये शिकलेलो आहे. Boiling point temperature of ammonia is -33 degrees centigrade at 1 atmospheric pressure. But here, as we have increased the pressure, so boiling point temperature of water as well as ammonia will also goes on increasing. But there is a huge difference. There is a huge temperature difference between boiling point temperature of ammonia and boiling point temperature of water. So here inside the generator, as we are having the strong aqua ammonia solution, strong aqua ammonia solution means maximum percentage of ammonia is present and water is also present, but concentration of water is lower. So here from that strong aqua ammonia solution, whatever ammonia will be there, that ammonia will easily get evaporate. Ammonia will easily get evaporate, and here there will be the formation of high pressure ammonia vapor. That water will not get boiled because water is having the highest, or water is having the much more higher boiling point temperature as compared to ammonia. That's why here from that aqua ammonia solution, strong aqua ammonia solution, ammonia will easily get boiled, or ammonia will easily get vaporized. And here at the outlet of generator, we will have the high pressure ammonia vapor. That means condenser pressure vapor refrigerant. And that high pressure ammonia vapor will be passed through the condenser. The function will be same of that is heat will be rejected. Here there will be the formation of high pressure, that is nothing but condenser pressure ammonia liquid. So here there will be the formation of liquid ammonia that will be received by the receiver, that will be provided to the expansion valve. So inside the expansion valve, here condenser pressure liquid ammonia will be expanded up to the evaporating pressure liquid plus vapor ammonia. That will be again given to the evaporator. Inside the evaporator, heat absorption process will take place at a constant pressure. Because of heat absorption, here liquid ammonia vapor will get converted, into vapor ammonia, but pressure will be evaporating pressure, that is nothing but low pressure ammonia vapor, that will be again supplied to the absorber. But what about the water which is remain after evaporation of the ammonia? ज्यावेळेस या ठिकाणी स्ट्रॉंग एक्वा अमोनिया सोल्युशन मधलं अमोनिया वेपराइज होईल, त्यावेळेस रिमेनिंग सोल्युशन जे राहिलेलं असणार आहे त्यामध्ये काय असणार आहे, मॅक्सिमम पर्सेंटेज ऑफ वॉटर असणार आहे अँड व्हेरी स्मॉल अमाऊंट ऑफ अमोनिया असणार आहे, जो की वेपराइज झालेला नाही तेवढाच अमोनिया असणार आहे. दॅट मीन्स देयर विल बी द फॉर्मेशन ऑफ वीक एक्वा अमोनिया सोल्युशन. So that weak aqua ammonia solution will be passed. Weak aqua ammonia म्हणजे काय? Weak aqua ammonia solution म्हणजे काय? कोण सांगतंय? Weak aqua ammonia solution म्हणजे काय? Maximum percentage of water and very small amount of ammonia. So that weak aqua ammonia solution is having the pressure as a condenser pressure or higher pressure. So that higher pressure weak aqua ammonia solution will be passed through the pressure reducing valve. So what will be the function of pressure reducing valve? To reduce the pressure. So that pressure reducing valve will again reduce the pressure from high pressure to low pressure, that is condenser pressure to evaporating pressure. So whatever that low pressure aqua ammonia solution will be there, or whatever that low pressure weak aqua ammonia solution will be there, that will be again supplied to the absorber. So that weak aqua ammonia solution, low pressure weak aqua ammonia solution will again draw more and more amount of ammonia vapor which is coming from the evaporator, or will absorb. That weak aqua ammonia solution will absorb maximum amount of ammonia vapor which is coming from the evaporator, and because of the same there will be the formation of strong aqua ammonia solution that will be again passed through the pump, and that process will continue. Now in some student mind, you will have the question like, why we are using that pressure reducing valve here. Why we are using that pressure reducing valve? For what purpose we are using the pressure reducing valve? Because we are knowing that whatever absorber is there, that absorber is working at a lower pressure. So that generator is working at a higher pressure. Absorber is working at a lower pressure. So to increase the pressure from lower pressure to higher pressure, we are using the pump. To increase the pressure from lower pressure to higher pressure, or from evaporating pressure to condenser pressure, we are using the pump. And to decrease the pressure from higher pressure to lower pressure, we are using the pressure reducing valve. One more point is there, whatever water is there, water is having the tendency. Here we are using the water as an absorbent. So water is having the tendency to absorb more and more amount of ammonia vapor. Water is having the tendency to absorb more and more amount of ammonia vapor at lower temperature and lower pressure. At lower temperature and lower pressure. त्यामुळे आपण काय करतोय, या ठिकाणी प्रेशर रिड्यूस करतोय. प्रेशर रिड्युसिंग केल्यामुळे काय झालं, ते जे काय वॉटर आहे ते काय झालं, लोअर प्रेशरला जनरेट झालं. आणि लोअर प्रेशरला काय होणार आहे, ते वॉटरची टेंडन्सी काय असणार आहे, टू ऍब्झॉर्ब मोर अँड मोर अमाऊंट ऑफ अमोनिया वेपर. आणि ह्या ठिकाणी तुम्हाला अजून एक कॉइल यूज केलेली दिसते. दॅट कॉइल इज कॉल्ड ॲज अ कूलिंग कॉइल. दिस कॉइल इज कॉल्ड ॲज अ कूलिंग कॉइल. आणि जनरेटर मधली जी काय कॉइल होती त्याला काय म्हणतो आपण, हिटिंग कॉइल म्हणतोय. तर कूलिंग कॉइल कशासाठी यूज केलेले आपण, कूलिंग कॉइल कशासाठी यूज केलेले, ज्यावेळेस हे विक ॲक्वा अमोनिया सोल्युशन त्या ऍब्झॉर्बर मध्ये येईल, ते विक ॲक्वा अमोनिया सोल्युशन काय करणार आहे, मोर अँड मोर अमाऊंट ऑफ वॉटर वेपर ऍब्झॉर्ब करणार आहे. ज्यावेळेस वॉटर वेपर ऍब्झॉर्ब केले जातील, त्यावेळेस काय होणार आहे, त्या वॉटर वेपरचं, सॉरी नॉट वॉटर वेपर, अमोनिया वेपर, ज्यावेळेस हे विक ॲक्वा अमोनिया सोल्युशन त्या लो प्रेशर अमोनिया वेपरच्या कॉन्टॅक्ट मध्ये येणार आहे, त्यावेळेस काय होणार आहे, मोर अँड मोर अमाऊंट ऑफ अमोनिया वेपर काय होणार आहे, ऍब्झॉर्ब केले जाणार आहे. आणि मोर अँड मोर अमाऊंट ऑफ अमोनिया वेपर ऍब्झॉर्ब केल्यामुळे अमोनिया वेपरचं कन्वर्जन कशामध्ये होणार आहे, लिक्विड अमोनियामध्ये होणार आहे. लिक्विड अमोनियामध्ये होणार आहे. ज्यावेळेस पेपरचं कन्वर्जन लिक्विड मध्ये होत असतं, त्यावेळेस काय होत असते, हीट रिलीज होत असते. आणि जी काय अमाऊंट ऑफ हीट रिलीज होणार आहे, त्यामुळे काय होणार आहे, त्या सोल्युशनचं, ॲक्वा अमोनिया सोल्युशनचं काय होणार आहे, टेम्परेचर इन्क्रीज होणार आहे. आणि ज्यावेळेस ॲक्वा अमोनिया सोल्युशनचं टेम्परेचर इन्क्रीज होईल, त्यावेळेस काय होणार आहे, त्या वॉटरची टेंडन्सी जी आहे अमोनिया वेपर ऍब्झॉर्ब करायची, ती काय होणार आहे, रिड्यूस होणार आहे. तर ती वॉटरची टेंडन्सी इन्क्रीज करण्यासाठी आपल्याला काय करावं लागणार आहे, त्या सोल्युशनचं टेम्परेचर कमी करावं लागणार आहे. आणि त्या सोल्युशनचं टेम्परेचर कमी करण्यासाठी आपण काय केलेलं आहे, ह्या ठिकाणी कूलिंग कॉइल यूज केलेली. आणि ह्या कूलिंग कॉइलच्या साहाय्याने आपण काय करतोय, त्या ॲक्वा अमोनिया सोल्युशनचं टेम्परेचर मेंटेन ठेवतोय, आणि जेणेकरून मॅक्सिमम अमाऊंट ऑफ अमोनिया वेपर काय होतील, ऍब्झॉर्ब होतील. आणि ही सिस्टीम काय होणार आहे, कंटिन्यू होणार आहे. So this system will be called as a simple aqua ammonia vapor absorption refrigeration system. समजलं प्रत्येकाला, समजलंय का प्रत्येकाला सिस्टीम, येस और नो? नसेल समजलं तर क्वेश्चन विचारा, काय समजलं नाही. हॅलो, समजलं नसेल तर क्वेश्चन विचारा. Have you understood the system? If not, then if you are having any doubt related to this system, or if you are having any question related to this system, you can ask me. Okay, within 2 to 3 minutes I will summarize this system once again. 3 मिनिटांमध्ये मराठीतून सांगतोय ती सिस्टीम अजून एकदा. सिंपल ॲक्वा अमोनिया वेपर ऍब्झॉर्प्शन सिस्टीम आपण काय केलेलं आहे, कॉम्प्रेसर फ्रॉम द पीसीआरएस सिस्टीम. पीसीआरएस सिस्टीम मधला कॉम्प्रेसर फक्त कशाने रिप्लेस केलेला आहे, पीसीआरएस सिस्टीम मधला कॉम्प्रेसर फक्त कशाने रिप्लेस केलेला आहे आपण, हा ऍब्झॉर्बर, पंप, जनरेटर आणि प्रेशर रिड्युसिंग वॉल, त्या चार असेंब्लींना आपण काय केलेलं आहे, पीसीआरएस सिस्टीम मधला कॉम्प्रेसर रिप्लेस केलेला आहे. बाकीची जी काय सिस्टीम आहे, म्हणजे हिथून हितपर्यंतची सिस्टीम, ही जी सिस्टीम आहे ती काय, सेम ऍज दॅट ऑफ पीसीआरएस सिस्टीम आहे. पीसीआरएस सिस्टीम सारखीच ही सिस्टीम आहे, म्हणजे कंडेन्सर, रिसिव्हर, एक्सपान्शन वॉल, इव्हापोरेटर, आणि फंक्शन पण काय असणार आहे, सेम असणार आहे. आता फक्त चेंज जो झालेला आहे तो एवढ्या सिस्टीम मध्ये झालेला आहे. जो काय चेंज झालेला आहे तो फक्त एवढ्या सिस्टीम मध्ये झालेला आहे. तो चेंज नेमका काय झालेला आहे, आपल्याला काय येत होतं, आपल्याला काय माहित आहे, इव्हापोरेटरचं जे काय आउटलेट असायचं ते काय असायचं, लो प्रेशर रेफ्रिजरंट असायचं. आता ह्या ठिकाणी सिंपल ॲक्वा अमोनियामध्ये ॲक्वा जो आहे म्हणजे वॉटर जे आहे ते काय यूज केलेलं आहे आपण, ऍज अ ऍब्झॉर्बंट म्हणून यूज केलेलं आहे. अमोनिया जे आहे ते ऍज अ रेफ्रिजरंट म्हणून यूज केलेलं आहे. आता वॉटर जे आहे ऍज अ ऍब्झॉर्बंट काय यूज केलेला आहे? बिकॉज वॉटर इज हॅव्हिंग द टेंडन्सी टू ऍब्झॉर्ब more and more amount of ammonia vapor at lower pressure and lower temperature. त्यामुळे आपण वॉटर ऍज अ ऍब्झॉर्बंट यूज केलेला आहे, अमोनिया ऍज अ रेफ्रिजरंट यूज केलेलं आहे. आता त्या ठिकाणी दोन मिनिटं. Wait for 1 minute. Let it. त्या ठिकाणी जे काय इव्हापरेटरचा आउटलेट असणार आहे, इव्हापरेटरचा आउटलेट काय असणार आहे? लो प्रेशर रेफ्रिजरंट पेपर असणार आहे. ते लो प्रेशर रेफ्रिजरंट पेपर आपण कशाला देतोय? ऍब्झॉर्बरला देतोय. त्या ठिकाणी ऍब्झॉर्बरचं इनलेट जे असणार आहे ते काय असणार आहे? वीक ॲक्वा अमोनिया सोल्युशन असणार आहे. ज्यावेळेस हे वीक ॲक्वा अमोनिया सोल्युशन ही अमोनिया पेपर ऍब्झॉर्ब करेल, वीक ॲक्वा अमोनिया सोल्युशन अमोनिया पेपर ऍब्झॉर्ब करेल, त्यावेळेस काय होणार आहे? त्या ठिकाणी वीक ॲक्वा अमोनिया सोल्युशनचं स्ट्रॉंग ॲक्वा अमोनिया सोल्युशन मध्ये कन्व्हर्जन होणार आहे. आणि ह्या ठिकाणी कुलिंग कॉईल कशासाठी यूज केलेले? ज्यावेळेस वीक ॲक्वा अमोनिया सोल्युशन, कारण की आपल्याला काय माहित आहे, वॉटरची पेपर ऍब्झॉर्प्शन कॅपॅसिटी जी आहे ती लो प्रेशर आणि लो टेम्परेचरला मॅक्सिमम आहे. त्यामुळे आपण काय केलेलं आहे? प्रेशर रिड्युसिंग वॉल्व थ्रू काय केलेलं आहे? त्या वीक ॲक्वा अमोनिया सोल्युशनचं प्रेशर रिड्यूस केलेलं आहे. आणि ह्या ठिकाणी ज्यावेळेस वीक ॲक्वा अमोनिया सोल्युशन अमोनिया पेपर ऍब्झॉर्ब करेल, त्यावेळेस काय होणार आहे? जी काही हीट रिलीज होणार आहे ती हीट रिलीज झाल्यामुळे काय होणार आहे? ह्या सोल्युशनचं टेम्परेचर वाढणार आहे. आणि त्या सोल्युशनचं टेम्परेचर वाढल्यामुळं वॉटरची अमोनिया पेपर ऍब्झॉर्प्शन टेंडन्सी जी आहे ती काय होणार आहे? कमी होणार आहे. तर ते टेम्परेचर मेंटेन ठेवण्यासाठी आपण काय करतो? ह्या ठिकाणी कुलिंग वॉटर यूज करतो. ज्यावेळेस ह्या ठिकाणी स्ट्रॉंग ॲक्वा अमोनिया सोल्युशन जनरेट होईल, ते स्ट्रॉंग ॲक्वा अमोनिया सोल्युशन आपण पंपच्या साहाय्याने काय करतोय? प्रेशराईज करतोय. आणि हाय प्रेशर स्ट्रॉंग ॲक्वा अमोनिया सोल्युशन कशाला देतोय? आपण जनरेटरला देतोय. जनरेटरमध्ये आपण काय यूज केलेले? हिटिंग कॉईल यूज केलेले. हिटिंग कॉईल थ्रू आपण काय करतोय? एकतर वेस्ट हीट किंवा स्टीम किंवा जी काही हीट एनर्जी आहे ती पास करतोय. आणि त्यामुळे काय होतं? ह्या ठिकाणी जे काय स्ट्रॉंग ॲक्वा अमोनिया सोल्युशन मधलं जे काय अमोनिया आहे त्या अमोनियाचं काय होतंय? पेपरायझेशन होतंय. कारण की बॉइलिंग पॉईंट टेम्परेचर अमोनियाचं काय फारच कमी आहे ऍज कम्पेअर टू वॉटर. त्यामुळं जे काही पेपर अमोनिया असणार आहे ते पेपर अमोनिया काय होणार आहे? हाय प्रेशर पेपर अमोनिया होणार आहे. आणि ते हाय प्रेशर पेपर अमोनिया परत कशा थ्रू पास होणार आहे? म्हणजे हाय प्रेशर रेफ्रिजरंट पेपर झालं ते आपल्या पेपर कॉम्प्रेशन सारखं कंडेन्सर, परत रिसिव्हर, एक्सपान्शन वॉल, इव्हापरेटर मधून पासून परत कशाला जाणार आहे? आपल्या ऍब्झॉर्बरला जाणार आहे. सेम सिस्टीम असणार आहे. फक्त ज्यावेळेस अमोनिया पेपर जनरेट होईल त्यावेळेस जी काय राहिलेली सिस्टीम, जे काय राहिलेलं लिक्विड असणार आहे ते काय असणार आहे? वीक ॲक्वा अमोनिया सोल्युशन असणार आहे. वीक ॲक्वा अमोनिया म्हणजे मॅक्सिमम पर्सेंटेज ऑफ वॉटर असणार आहे अँड व्हेरी स्मॉल अमाऊंट ऑफ अमोनिया पेपर असणार आहे. ते वीक ॲक्वा अमोनिया सोल्युशन आपण कशा थ्रू पास करतोय? प्रेशर रिड्युसिंग वॉल्व थ्रू पास करतोय आणि ते नंतर कशाला देतोय? ऍब्झॉर्बरला देतोय. या ठिकाणी तुम्ही जर बघितलं फ्लो ऑफ वॉटर जो आहे त्या ठिकाणी फ्लो ऑफ वॉटर म्हणजे फ्लो ऑफ ऍब्झॉर्बंट. ऍब्झॉर्बंट जे आहे ते फक्त एवढ्याच सिस्टीम मध्ये पास होते. ऍब्झॉर्बंट जे आहे वॉटर ते फक्त एवढ्याच सिस्टीम मध्ये पास होते. त्या वॉटरचा ह्या साईडला येतंय का? ते वॉटर ते येत नाही. आणि जे काही रेफ्रिजरंट जे आहे, रेफ्रिजरंट ऍज अ अमोनिया तुम्ही जर बघितलं तर रेफ्रिजरंट जे आहे ते कम्प्लीट सिस्टीम मध्ये पास होते. म्हणजे इथून इथपर्यंत असं कम्प्लीट सिस्टीम मधून ते रेफ्रिजरंट पास होते. आर यू गेटिंग? सो दिस इज कॉल्ड एज अ पेपर absorption refrigeration system, aqua ammonia vapor absorption refrigeration system. Are you getting? So we'll end our lecture here. You can write your roll number in the chat box. Write the roll number in the chat box. Today full day lectures will be there because today there will not be any type of training.